We've got Anton Chavakin. He's currently a senior security advisor in the office of the CISO at Google Cloud. Now, Anton joined Google via, I believe, right, Anton, the Chronicle acquisition. But I know Anton previous to all of this because of his various publications at Gartner as a distinguished analyst. He's a multiple-time author, written a number of books as well. And then, of course, we've got Brandon, who I've been working with for a number of years, a good friend here, SANS instructor, the lead author of Sec 510, the class all about cloud security controls and mitigations. Previous to that, he was a security engineer at Zoom and other large organizations. Now, Anton and Brandon are partnered here together. Well, hey, because they've had good conversations before. Anton and Brandon actually spoke together previously on the first season of the Cloud Security Ace podcast, which Brandon had actually hosted. Now, with that, I'm going to go ahead and turn it over to Anton. Brandon, everybody, let's give them a virtual round of applause here. And we'll kick things off here with their talk on evolving cloud security with a modern approach. Anton, Brandon, take it away.
Thanks, Frank. Looking forward to kicking things off by talking about how we can evolve our security approach in the cloud, because using the techniques that we've used on premises won't necessarily translate there. Am I on the... There we go. Yes. So Frank already gave a really good introduction of both of us, so I'm just going to kick things off. So first and foremost, the cloud is basically the only frontier at this point. People say it's the final frontier, but it's basically becoming the only frontier where people are targeting the cloud extensively. I've seen some statistics that have said that 80% of incidents have happened in the cloud versus 20% on premises, although that's from the Unit 42 Palo Alto Network report. I'm not really sure where they got those numbers from, but if that's even close to being true, that is really, really scary stuff, especially because this other finding, this other research that I found from the Thales group says that 60% of corporate data is in the cloud. So there's almost like a mismatch between the two of these environments, as if people are uniquely not prepared to deal with the cloud, or the cloud is somehow uniquely insecure. Now, I don't think it's the case that the cloud is uniquely insecure. I think it's more on the first one, that people do not necessarily know how to evolve their techniques to deal with the cloud. So we're going to talk about some of the things that we can do to handle that.
Perfect. And I want to gently argue against the perception that does exist in some circles that the cloud may be uniquely insecure. And I want to make a strong opposite argument and then provide some nuance to start our discussion. I think that when I was a Gartner analyst, a good number of years ago at this point, we've had a number of people calling us with questions about this very topic. Hey, is cloud secure? Can I use it? And it's a very, very lively debate, probably around 2014-15. So at this point, 10 years ago. And over time, the debate largely subsided, because ultimately it became very clear with a very robust fact base that cloud is secure. And then a lot of people were like, oh, wait a second. So there are all those good reasons why cloud is more secure. Cloud providers are well resourced. They have really good security teams. They hire the best of the best of the best engineers and have good resources to secure cloud. So why are there still breaches? Why are there still examples of badness in the cloud? Could you show me the next slide, please? In fact, when we look at our own data for our own cloud and a few other data sources from a report we call Google Cloud Threat Horizons, we definitely see things not indicating lack of incidents. I mean, there are incidents, there are data breaches, there are concerns. And when we look at how the attackers get in, we observe something very interesting. They don't observe in because cloud is insecure. They get in because cloud is not used securely. So think about the credentials. Think about the misconfiguration. Think about the other things that aren't in the hands of a cloud provider, because ultimately, if people want to set the empty password on their cloud-hosted database, it's very hard to blame the provider for it. And configurations, misconfigurations and weak credentials and various credentials abuses, travel and migrate from threat report to threat report. Ultimately, it's pretty much a consensus view that this is what gets you in the cloud. In fact, I had some of my Mandiant colleagues bring up that the identity, a well-known identity system, which rhymes with directory, is very commonly the reason for certain cloud breaches, right? The challenge is identity and how people do it. What do the attackers do when they get into the cloud? Next slide, please. That's another data set from the same report, which indicates, runs off our own data. It indicates what the attackers actually do. This is a bit of a sidetrack for our conversation, but it's interesting that crypto mining still tops the charts of what the attackers do. Notice that a lot of this indicates probably not necessarily a high sophistication of the attacker. This is not some kind of a top tier data theft, even though, of course, there's a degree of that. But it means that the attackers often find it fairly easy to abuse misconfigured, poorly organized, poorly run cloud environments. So what it means, at least in our interpretation, is that people are just not securing cloud the modern way. Next slide, please. So today together, I mean, me and Brandon would try to explore this and basically provide instructions and recommendations on how to secure cloud from the user point of view so that your cloud use is secure. And this is another line that I would quote from my former employer, namely Gartner, that cloud is secure, you're just not using it securely. This was born in 2015. I specifically checked with an analyst who created this line, who's retired by now, and he said, yes, there's a date in 2015 when he concluded that cloud is in fact secure, but many clients, many organizations just not using it securely. So why? Why is this going on and what we can do to fix it? In our paper, we highlighted the fact that there are certain practices in certain domains that people just practice essentially the old-fashioned way, the pre-cloud way, and the result is that it doesn't match. First, as we mentioned before, as Frank mentioned the podcast before, I run a podcast, and on the podcast we ban the line "cloud is just somebody else's computer." Why do we ban this line? Why do we kind of go pretty, aggressive on the guests who basically utter the line, just somebody else's computer? Because cloud is most certainly not just somebody else's computer. And ultimately, cloud involves somebody else's computers. But it's this word just is what sends you down a very wrong security path. If you assume that cloud is just somebody else's computer, everything you know about securing your own computers should in theory apply, multiplied by shared responsibility model. But what happens in reality, if you try this, you will end up in the Threat Horizons report or in many other threat reports that many other vendors and organizations publish. CSA published their top threats. Ultimately, the story here is that if you try doing cloud security as if it's the rented colo or a data center, you will end up in bad shape. And then people say, okay, I got it. Thank you. Thank you, Anton and Brandon. You convinced me. I shouldn't do it this old way. I should do it the new way. What is this new way? That's what we are here to talk about. Next slide, please. We are also well known for biting more than we can chew. So while this presentation is kind of an ad for the white paper, which we wrote, we wanted to highlight a few domains where this type of new thinking, new approach is especially critical. So admittedly, in the next 40 minutes, we probably won't go through all of them, but we'll go through some of the fun ones. Of course, we'll go through configurations, through identity, we go through governance, and we'll touch upon the detection, response, and data security as well. There are many areas where doing cloud security the old-fashioned way or the just somebody else's computer way will get you in some pretty massive trouble. And I think probably Brandon's favorite area, AppSec, is virtually present in this group as well. So what we want to cover next is what does it mean to do it differently and how do you do it different? Brandon, all yours for now.
Excellent. So I think it was a great point to mention that it's not just someone else's computer. There are a lot of different services that we integrate with, a lot of platform as a service, in addition to our infrastructure as a service. And there's a lot of configurations that are involved here. Now, some of those configurations are binary yes or no benchmarks, whether or not you have encryption on, for example, whether or not you have an administrative port open. But there's a lot of other ones that are really, really business contextual, One example of that is identity and access management. The policies for IAM are extremely contextual to your use case and your business. So having a siloed off cloud security team doesn't really make sense in that model because they can't just prescribe solutions for the entire enterprise without getting into the granularity of what the developers and operations folks are trying to accomplish. So there may be different teams that are involved in the process, but they absolutely need to collaborate with one another, such as the people that specialize in identity and access management, the people that specialize in creating golden images with workload image management, as well as the actual people that are building the things. They need to understand IAM and workload image management to a certain extent, but they can't be experts at everything. That's one of the problems that I have with DevOps and then DevSecOps is that eventually you give these developers basically every job in the organization. Why stop at DevSecOps? Why not do DevSecOps QA? Why not do DevSecOps QA finance, etc.? And it gets really out of hand. So you'll have your DevOps people that are actually building the thing, doing the best they can with guidance from these other groups. One of those groups, as mentioned before, are the groups that work on workload configuration and patching. I've seen far too often clients that have countless types of images out there, countless different operating systems with different configurations, and that's just not scalable. You'll have inconsistent configuration, inconsistent workloads, and this can result in inconsistent vulnerabilities, where some of them are vulnerable and some of them are not vulnerable. And in DevSecOps in the cloud, we also want to have ephemeral systems where instead of just manually patching workloads, we're going to instead recreate workloads from this updated image. That will be the only way that we can ensure that the configuration is consistent. And it has some added benefits, such as not having servers run indefinitely, meaning that if there's any command and control server, that will be broken every time that you rebuild the server, for example. So we need to ensure that we're using our images in a standardized way, is basically what I'm driving at. Then with identity, as I mentioned, there are so many nuances associated with identity and access management. So many different components. Who is able to do what, but also on what resources. And while the cloud providers do a decent job at giving you some built-in templates of what actions you should be able to perform as a user of this particular entitlement, they don't provide anything when it comes to resource control, because the resources that you need to access, once again, are extremely business contextual. Amazon, Google, Microsoft, they can't look at a name of a bucket and say that this is sensitive or this is not sensitive. That's your job. And as Anton mentioned, if you have a mistake in the cloud, it's because you've used it improperly. I will go ahead and supplement that, though, that I believe that the cloud service provider is responsible for educating the users of their cloud as much as possible, as well as give warnings when people are doing things incorrectly. And there are so many different places where things can go wrong. And I hope the cloud providers will continue to improve on educating their customers. But also, SANS is here to help with our educational material as well. One area that people are thinking about more so nowadays is just-in-time access management. People don't need to access systems indefinitely. They only need it for a period of time in which they are going to do their various jobs. And that's a really good idea in practice. How people gain that entitlement is kind of the jury's out on that one, because if you have the ability to escalate your privileges, what's stopping you from escalating your privileges in the future at any time that you want? So there are various systems that are being created to try to solve this problem, but I don't think we have a consistent solution to this problem yet, but hopefully that will continue to evolve.
And of course, network security makes an appearance. I've met enough people over the years who basically try to minimize the role of network security in the cloud and assume that, well, identities were the name of the game. Yeah, NetSec, what are you going to get a firewall in the cloud? What are you talking about? So it's kind of interesting how sometimes people over pivot from too much obsession about the old way to sort of assuming that the new magical way would magically fix everything. And ultimately, some of the mistakes that I mentioned in the threat horizon data and other threat data, when I say, oh, a configuration mistake, it can be a configuration with network access. It can be a configuration with quote unquote firewall, or as I prefer to say, firewalling, because it may not be a firewall. It may be a technology that is capable of limited network access. So to me, the access review that people apply to IAM, least privilege, all other fun things, a version of that is essentially done for network access. And in my mind, in many cases, the network access and IAM are sort of like much bigger friends in the cloud than they are on premise. There are certain overly permissive cloud access may apply to IAM, it may apply to images and systems and services being public where they really have no business being public, or would have other type of segmentation control. But a more fun one and more fun and interesting difference between doing the cloud network security in the cloud the old way versus the new way is this kind of lingering obsession with the hard shell soft center. I think it's very, very clear to us, and by us here, I mean people who lived in the cloud for quite some time, with not only Google Cloud, but other cloud providers and their cloud native clients, that you really don't do hard shell soft center in the cloud. You kind of do hard shell hard images, or you do no shell hard images. In that sense, the reperimetrization or perimetrization of each workload, kind of zero trust style, access control, applied to images and services is kind of how you do it. And when people read our papers, they read Beyond Corp, the paper that started Zero Trust, at least to an extent, and its newer version of Beyond Fraud, which is about network access, zero trust style access between workloads. They realize there is a lot of access control configuration going on, and they think, wait a second, I kind of want my hard shell. I kind of want my perimeter firewall and everything soft. No, it's not great, but at least I conceptually understand it. So this is unfortunately a mistake. If you stick to hard shell soft center, you will not have a good time in the cloud. You would, because again, you will be one IAM mistake away from a breach, but also you'll be one network configuration mistake away from a breach. There are many ways, this is good news, many ways to run network security the modern/cloudy way, where you do apply workload style access controls. It doesn't mean you have to write rules about which VM can talk to other VM. There's a lot of microsegmentation startups. There's a lot of technology cloud providers deliver on making this much more logical and much more coherent. But ultimately, NetSec in the cloud isn't just hard shell. And if you can do hard shell, you cannot do hard shell, but you can absolutely have to do hard images and hard services. And there are many ways in the cloud to actually make it happen. Isolation boundaries can spread and not drown you in the process. I'll leave it at that.
To add to that, a lot of people say that identity is the new perimeter. I don't know if anybody else has said this before, but what I like to say is identity is the new perimeter, but it's not the only perimeter. The same skills that we've learned on premises can be used effectively in order to protect our assets in the cloud. Even the data that's being stored in platform as a service can be protected with network controls using things like private endpoints. So I wouldn't throw it completely out, but I definitely think identity is a critical thing that people maybe don't fully understand when they migrate to the cloud. Now let's talk a little bit about high availability. At least in theory, the cloud is much more resilient and much more highly available. They have all of these regions, and within those regions, we have highly available availability zones, for example, is the terminology in AWS and Azure. I'm not sure if that's the same term in Google, but availability zone is one of the terms that is commonly used. And I think people look at that and they kind of just wave away at it and say, oh, availability zones are going to solve all of my problems. And we've actually seen some outages recently where that has not exactly been the case. There was one AWS outage in late 2021 in which a single availability zone in the US East 1 region went down, and it resulted in some performance issues. It didn't take everyone down, but there were still some performance issues. So I think just like we should not think that the cloud provider is just going to solve all of our security problems, I also don't think we should think that it solves all of our availability problems either. Now, there are several approaches you can take to more easily fail over in the cloud. One of those things is to use multiple regions. I think that people skip this step. A lot of the times, people say, oh, I can't depend on one cloud provider. Therefore, I should have multi-cloud failover so that if things go bad in Google, I can fail over to AWS or Azure. But they don't consider the simpler approach of going multi-region first. I mean, basically everybody puts their infrastructure in US East 1 in the case of AWS. I don't know why people are okay with this, because US East 1 is the region in which basically everybody lives, and also where all of the changes typically are put out there, which is great. New features, fantastic, but perhaps we should spread our load across multiple baskets instead of just either putting all of your eggs in one basket or say we have to go multi-cloud, because multi-cloud is very, very difficult. Having these cloud providers talk to one another literally is very, very difficult. But I'm glad that we can have the representatives of the clouds here talking together. Maybe they can get their services to play nicer together.
And this is one more of the fun ones, data security. I would say that it's an area that has puzzled me for a good number of years. Again, going back to my Gartner days, those of you who's tracked my career, I know that when I say that, it means 2019. The data security seemed to be having a moment in the spotlight because of quote unquote data breaches and data theft and data loss, not just data everywhere. But when you talk to people actually deploying security, unfortunately, you see a lot more of infrastructure security. So it's kind of a bit of a mystery. Many years ago, I've caused a minor storm on Twitter by saying that there aren't that many successful data security companies compared to firewall makers, antivirus makers, a lot of other security gear makers. DataSec just isn't what made people rich, to use an analogy here. So in the cloud, data security is another big pillar that's elevated, kind of compared to IAM. And there are good news and great news. And let me start with great news first. A lot of things that were tricky to encrypt on premise, and again, that's another debate I recall from my analyst days. Hey, should I encrypt every disk on every server in my data center? Some people said yes. Some people said no. Why? Nobody's going to steal a server from your data center. So it was kind of a debate. That debate is very fortunately over in the cloud. To use our own examples, in Google Cloud, all data is encrypted by default. There's no, but can I have encrypted image? I mean, there's no such thing. They're all encrypted. There's only encrypted. That's the choice, encrypted or encrypted. Now, admittedly, if you want to do fancy things with your keys, we can tell you a lot of interesting additional details to that. But ultimately, a lot of data security, encryption, data discovery, data tagging, classification is way easier in the cloud. And that's I'm not just saying that because I work for a cloud provider. Again, encryption is easy because it's just done for you. It's just done, period, full stop. You succeed before you start the project. Admittedly, there's some nuance about the threat models, what threat model it helps against. But hey, people show up at our door and say, can I have encryption that protects my data from you, the cloud provider? And while it may sound like a completely bizarre question, the answer is yes. We can give you an encryption that would protect your data from us. Admittedly, a niche use case, but technology for this exists, and I'm happy to give you some highlights. That's very easy to do if you have the infrastructure. Same with discovery. You move massive volumes of data. Maybe you're training your own AI models. Maybe you do some other modern 2020 stuff. Maybe you're using Gen AI. A lot of data moves around, and a lot of data may involve corporate secrets, may involve sensitive data, may involve data that you didn't think was sensitive, but it really was. A very fun case. But the fact that the discovery, encryption, tagging is built in, is already there. And moreover, for some cloud providers, again, this is kind of me with a brief moment in the marketing hat, some of the tools are actually even multi-cloud. You can do data discovery across providers, across stores. To me, things like what we used to call Google Cloud DLP, admittedly, people pointed out that it's not really DLP, it's more of a overall sensitive data protection platform, deliver exactly that by telling you where data is across the repositories, telling you how sensitive data is, and helping you discover certain elements of data maybe you didn't know were there. We certainly see people load sensitive data in the cloud or load data in the cloud and then later discover it's sensitive. How about that? In this case, they may need to apply additional controls based on what the data discovery infrastructure is telling them. And a lot of this was so hard on premise that many organizations just flat out didn't do it. Again, encryption example, the data discovery examples were at least at most incomplete. In the cloud, a lot of this is just done, or a lot of this is just done much easier. So the fact that you can have data protection against cloud provider is kind of a more niche use case. Next slide. I'm going to highlight it very briefly. We separated key management from data security and recombined it with secret management. There's a reason for that. Remember where we started today. We started with a discussion of misconfiguration and identity problems. One of the very popular misconfigurations and identity problems is, of course, leaving some kind of access credentials, username and password pairs, or some other cryptographic keys in code, in public repositories, and many other places. So secrets, not only passwords, but other type of secrets, down to all the way down to SSH keys, tend to spread, and they tend to spread in places where you really don't want them to go. So there are two ways about it. You can be kind of cruel about it and say, we're going to block all your badly managed credentials, or we can be nice about it and say, hey, we'll help you discover them. And ultimately, the correct answer is yes to both. You do want a way to automatically block access secrets if they're in absolute abysmal situation, like if people already are abusing them today. You probably want them blocked immediately without us calling you and saying, hey, I think you have a key in PHP code in GitHub and it's open, and hey, what do you think? Is it a good idea? Yes, no. Oh, no. Okay, what do you want us to do? Like, that's a little silly. For some scenarios, you just want it to be gone and you want an easy way to get properly managed credential. The same applies to encryption keys. I did mention encryption for every cloud asset, at least in GCP. And people say, okay, great, encryption, but who has the keys? And in this, of course, if you insist on keeping the keys under your pillow, we can provide that. If you insist on having the keys only under your pillow and nowhere else, meaning you would apply some form of hold your own key approach with external key manager, that can also be done. The point is that it's not only more secure, it's also more flexible and ultimately easier to configure and more intelligent. I do sound like a cloud evangelist. Hey, I am, well, to an extent, but it also happens to be the truth. Key management is dramatically simpler. Revocation is simpler. Various degrees of addressing the threat model, various degrees of security. If you want an HSM, sure, you can have an HSM. If you want your own HSM, you can have your own HSM. The situation is that there's a range of options, and there's a range of supporting technology, including some quote unquote AI powered, to help you find the missing credentials and deal with them. So this is a very fun area. Next slide. But the next one is actually even more fun. So those of you who watched me, write and speak about security know that, of course, log management would make an appearance. Now, the difference between doing log management in the cloud is interesting. First is we do see a lot more data, but we also see a lot more different data and a lot more different context. What do I mean by context? Look at traditional logs from a server. Such and such user authenticated the server IP address such and such. A very logical on-premise log. People from the 2000s, 90s, 80s, and perhaps even 70s would recognize that log. 70s would be a mainframe, I guess. So the context is there's a server, there's a user. It's probably a human user authenticated to a server and gain access. And that log would be generated in most on-premise systems. Now, in the cloud, there would be a system and there would be somebody authenticating to a system. But that somebody may be a server. It may be another workload. It may be a machine. It may be a component of an application. And where they would authenticate to would not be necessarily a server, even though it can be a VM. It can be a service. It can be many other things. It can be a cloud native data store. So logs may be the same, blah authenticated to X, but the context is quite different. And if you just get a shovel your cloud logs into your traditional SIEM, that SIEM would be quite befuddled. And I've seen examples where the logs can be parsed, but the logic and the context just don't get it, don't get it to a SIEM. So that's why I became a very passionate proponent of cloud native SIEM. Of course, for a brief moment before acquisition, used to work for Chronicle, which is now called Google SecOps. If you're doing log analysis, whether you're using a SIEM or log management for cloud logs, you want a system that actually can speak cloud, and not the system that was born on premise in the 1990s or 2000s and then was kind of spray painted to get cloud. In most cases, it won't be good. It may be okay for a while, but ultimately, cloud log analysis likely requires a cloud native system. It's mostly because of the context, but also because of volumes. If we start saying, hey, give me this eBPF observability data, give this in-app telemetry, it has a lot more very alien context. It would not be user John Smith connected to server XYZ2. It would be a lot more obscure for an on-premise mind, and it would be very clear to a system that understands cloud. That's why in many cases, you'd have much easier time storing data in the same cloud, ideally using a SIEM from the same cloud provider. Now, a lot of other people expect me to say, what about the AI? Would you have some kind of magical AI that just looks at my data and tells me everything I need to know? And of course, my answer would be, yeah, we have that. But the problem isn't that we have that or we don't have that. The problem is that much of the work of detecting threats in the cloud would still be done by, well, humans using tools like AI, whether they would have the natural language search or a much better user experience where the events and activities are much better explained, then the context is incorporated, and it's much more logical and clear what's going on. It would still involve humans. We are using the machines, including some really impressive machines, to analyze data at scale, but the role of a human analyst is kind of not even diminished. In fact, it's escalated in some cases because of threat hunting scenarios, because of other things where machines are critical, but humans are, well, is who's in charge. So to me, that's why when you look at, hey, but ML would do it, or AI or of some sort would do it, the answer is yes, but there would be a person behind the steering wheel. Next one. Enough about logging. I can talk for another 6 hours, perhaps.
I was just going to say, don't
Yeah.
talk too much about how AI can solve all of our problems, because Ahmed and I are going to talk later about how it can solve every single one of our problems and put us all out of a job. So stay tuned for that talk.
Excited. Excellent. So an auxiliary to this, login and log analysis, detection and response is, of course, IR and forensics. And this is where another interesting conundrum comes up. If I look at traditional forensics going back many, many years, I don't know in how many years, many minds go straight to these images. And a lot of the same thinking carried over to cloud. And they say, give me a VM, give me a VM. They sort of assume that to do forensics in the cloud is to stash a VM disk in some cloud storage and then do the analysis. So people whose minds are framed by the on-premise forensics assume that cloud forensics means VM images. And then they show up in a more modern environment, in a more cloud native environment, and realize that almost nothing runs in the VM image. And they're like, oh, I don't understand. How do I do forensics? Well, that's the point. Cloud forensics does change. Now, would it be useful to still have a skill of analyzing virtual machine images? Yes. Would some evidence be stashed in VM images? Most likely if customer is using VMs. Will VM-only forensics get you very far? No. Unfortunately, the answer is no. And there are even whole startups that develop to do cloud detection response or even cloud incident response. I think my former colleagues at Gartner were trying to define a whole market space for cloud forensics. The point is that there's a much wider range of forensic artifacts. Not to be excessively self-serving, we've run on our podcast, we've run an episode with somebody who does essentially cloud forensics for us, for our own internal teams, for Google. And I would wholeheartedly recommend this episode. I'll drop the link in the Slack because some of the things that people assume to be true is very much not true in the cloud. And some of the things people assume to be possible in fast-paced cloud environments end up being even faster. And I think the episode was based on the Ghostbusters theme because ultimately, who do Ghostbusters call when they need help? And you will know the answer to the question. You would call Ghostbusters, but who would they help? So next slide, please. I think this is probably the most expected and also at the same time maybe the most marketing slide we have in the deck. But ultimately, everybody pushes to reveal some kind of AI magic and tell how all these problems will be solved. I'll defer to Brandon for the bigger picture. I'm going to go a little bit narrow here and say that when Gen AI showed up, a lot of people went on a quest for use cases. If you've been to RSA conference this year, you would see that a lot of vendors delivered all sorts of annoying AI-centric messages. And a lot of people I met in the industry were kind of not super happy about it. They assumed they all exaggerate. My reaction was, no, 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 wait. We are in the use case search stage. We are looking where to apply this technology. We are looking where Gen AI would help. And given that we have a bit of a head start, given that most of this tech we invented, we've discovered some of the technologies and some of the use cases, and some of them are quite unexpected. If you expect Gemini or some other AI to like look at your logs and tell you what you know, what you need to know, that use case is perhaps not where I would go first. But if you have a lot of alerts and you have to need help deciding what to do, and you need to have a more shaped narrative out of the alerts and understand it and get a story, that's a great use case. If you want one system to talk to another system where you want to convert SPL to URL or something, where Gen AI would do a really good job. Same with automation. If you're trying to create a playbook, Gen AI-based tools create pretty mean playbooks out of what they know about your environment and, of course, security in general. A lot of this stuff is quite fun. A lot of this stuff is developing very rapidly. And a lot of this stuff would work well, yet, as I continue to insist, would not put most of us out of the jobs. At least that's my impression. I think there are enough of my former colleagues from both Gartner and Forrester has written on how the humanless SOC or humanless security team is not a thing. It's probably not coming anytime soon.
I think that these trends are going to continue to go on. I think that despite the fact that the modern cloud provider has been around for almost 2 decades, I think we really just have not fully gotten a hold on all the security nuance here. I think that identity and access management is going to become an even bigger problem that we need to work with. We need to figure out how to use it effectively, especially as we get into multi-cloud environments where we need multiple clouds to talk to one another. The identity and access management involved there is quite cumbersome. Configuration is always going to be the issue at hand. But again, I want to mention that it's not just checking a box or not checking a box, because eventually that's going to be a commodity if it's not already. But there are some things that a tool that doesn't have context really just can't solve. Maybe with a combination of AI and human configuration description, we can get an actual solution, but a tool out of the box is not going to solve those problems without at least us providing some level of context in some form. Data protection is always going to be the core thing that we care about, because that's usually the crown jewels that we care about. And there's a lot of things we're going to have to grapple with, especially as AI continues to grow, both for our defenders and for our adversaries.
I think that IAM centrality is continuing to be a fun theme, and people, again, looking at threat data, looking at the compromised data, we will still be circling between IAM problems, configuration problems. And hey, there's a Venn diagram, IAM configuration problems, which means you can actually make an IAM mistake in IAM configuration, privilege. A lot of this requires us being cloud providers in this case, all three of us who are represented at the event, to do a lot more to help clients. At least that's my belief, is that the shared responsibility is fine, but we do want something which we frankly call with a somewhat marketing term shared fate, where we try to get more done to help the other side, the client side, namely that our IAM would make IAM mistakes less likely, our misconfiguration would be watched by various machines that would give you advice. Long story, which I don't want to dwell on again because it is a SANS event and not a sales event. But the point is that cloud providers can do a lot more to help the client sitting on the other side because, hey, we built the cloud, we have more resources, we know how to do it, and it's kind of our cloud. So even something that sits on the other side of shared responsibility can be substantially helped by the cloud provider. Hence, identity, hence config mistakes, hence various student on data security. So think about this. These first three things we highlighted: IAM, config mistakes of various types, and of course, data security would come up as areas of interest, as areas of concern, as areas of priority for cloud security, but also areas where cloud providers can do a lot more and will do a lot more, at least we will, to help clients not make mistakes on their side. Because ultimately, cloud is secure, are you using it securely line? It's kind of, as another analyst said, a little bit blamey. Cloud providers, in my mind, should do more so that security concerns don't happen in the cloud side. If you remember the debacle of a recent breach at a cloud storage provider, we will discuss at our panel. The responsibility is very unclear. In fact, at our cloud provider panel, it would come up as a bigger focus. The other point I wanted to make, and not before I make the AI point, of course, is that a lot of privilege management, a lot of IAM would kind of stop being, hey, I'm an IAM admin, I'm going to admin IAM once a quarter. A lot of this would run a lot more continuously, a lot more privilege by request, access minimization, a lot more dynamic and fluid, which really means it would be better, but it would also mean it would be a lot more machine dependent. It wouldn't be about, hey, I'm going to write the rules for my entire enterprise. Your enterprise would change tomorrow morning when a team somewhere deploys code somewhere. So a lot of what you knew about the on-premise environments just flat out not right in the cloud. And if you approach security with that 1990s mind, you would go very off. And I think to me, that's the theme from our story today, is that doing cloud security as if it's just somebody else's computer will never succeed, never ever succeed, even for lift and shifters, even for people who replicate their entire environment in the cloud, because cloud actually is different. And in my opinion, better, but better only if you learn how to cloud. And yes, I think Google Marketing does use cloud as a verb, so I guess maybe I'm allowed to. So learn how to cloud, and then you can have your secure cloud experience.
Awesome. Before we get into Q&A, I just wanted to say it's always great working with you, Anton. We've had a lot of great conversations, and I dropped in the Slack 2 of the conversations we've had in the past for those who might be interested. You are on episode 2 of the SANS Cloud Security Podcast, and I was on episode 111 of the Google Cloud Security Podcast. So if you want to hear us talk a little bit more about various different topics, we're featured on those 2 episodes.
All right. Hey, great presentation. With that, we have a little bit of time for some questions that have come in. And the first one here is, hey, as you pointed out, lots of issues are because of misconfigurations, people or mistakes being made. What can be done or what are the cloud providers doing to minimize the possibility of these misconfigurations?
I think that there's multiple pillars to that answer. I think
your microphone disconnected.
Sorry, yes. Let me test what's going on. How about now?
Yeah, you're good now.
Yeah, okay. Sorry. So there are several pillars to that answer. The first pillar is, of course, what we call secure by default, secure by design. Ultimately, if we build the system in such a way that the less secure way becomes either not an option or very undesirable option or very friction-prone option, people would sort of gravitate to more secure ways. There's a lot of nuance to that. And of course, this is very clear in situations when somebody shows up and says, just enable MFA. And everybody nods, yep, just enable MFA. It's going to be much better. But then they drag out some app that they wrote in 1998 and then migrated to cloud without any change. And that app requires username and password hard-coded in code somewhere. I mean, you enable MFA, the app dies. And if it's a hospital or some other facility or God forbid some control facility, you can't have the app die. So MFA, except for this one place. So secure by default works as a philosophical route to make those mistakes less likely. But beyond that, a lot of technology that makes the secure way almost inevitable. I mean, I think my boss here, Phil Venables, likes to say that he wants to make this inevitably secure. That means that for most scenarios, whatever the client does, the state of the system remains secure. This is way easier said than done. I'll give you that. But there's a lot of power that can be built by the cloud provider so that customer would make the secure choice. The secure choice would be just as easy as the old choice and would gently educate some of the really bad choices out of people just because you've used to do it in your data center in the 90s behind 5 layers of firewall does not mean you should do it on the API endpoint exposed to the public. Like, no, you should do it differently because it is different. To me, education, secure by default, automation and advisory recommending systems like our IAM recommender is where the answer is. But there's no like one answer. Here's the magic wand. Swoosh, it's done. There would be multiple pillars to that.
I want to add on to that a little bit coming
Mm.
from a non-cloud security provider. I don't work for Google, Azure, or AWS, is that there is an incentive for the cloud providers to not necessarily be secure by default. The cloud providers care about security, but they also care about usability. And when those two things are in conflict, the cloud provider is likely going to pick the option that maximizes usability because that increases the adoption of the cloud provider. So I don't think that's inherently problematic. I think that we all need to do a better job of explaining how to use these services better and to make it very clear that when you use the defaults, the impact of using those defaults. And I think if we can improve on that education, the defaults won't matter nearly as much.
Yes, I think that I want to very gently push on this, given in the light of recent events, where again it would come during our panel, but I'm kind of doing a bit of a spoiler. Remember the Snowflake breach, right? What is interesting about this was the media reaction about who's at fault, a client or the cloud storage provider. It was very interesting that I bet that if they can have a time machine and fly back, they probably would make MFA mandatory. So usability choice over security in retrospect was not the right choice. And I think at this point, almost everybody admits that. So I think that there would be situations where a cloud provider would choose security over usability, or there may be a way to have usable security. I mean, admittedly, if you hire enough PhDs and you pay them enough money, they would invent the way to have high UX and high security. And that's where my faith is that a lot of this would be solved in a way that's both secure and usable.
Hey, we only have time for one more question. There's many others that have come in that we will try to cover them on our panel at the end of the session overall today. This one is Google specific. Where do you find information on using Gemini to create a playbook based on the various Google services? How does it work?
This is actually part of Google SecOps product stack. So a lot of this is in the Google SecOps documentation. I can probably find a link, but if you search for Google SecOps, you would see documents on using the Gemini for this and other tasks.
All right. With that, thank you so much to everybody. Let's give Anton and Brandon a big virtual round of applause here. Thank you very much.